Hey guys, I just want to give you a quick intro video into how to do an end-to-end workflow for scanning, modeling, and printing. I have this lightsaber that I got from Disney World. I was there with my family, and yeah, I think that'll be a good example for us. So, apologize in advance. I'm not like a professional YouTuber, but just want to kind of show you guys what I go through to do this, and we're going to do it in real time. So, got the lightsaber. I'm going to be using the RaptorX for this. This is my little turntable that I made, just a little lazy Susan. I put a bunch of dots on it and some other things. This is the lightsaber itself. You're thinking about how I'm going to orient it here within this space. Not going to do anything crazy here. We're not going to go for full fidelity. I'm just going to get a good enough scan and get the geometry I need to do this. Talking about the needing some vertical reference so that I can get the scanner down low, right? You don't want all your points just to be on a flat plane, right? They're positioning a little bit better, so I'll be able to get all the way around the thing. And let's jump into this. All right, so coming into Creality scan, first thing we'll do, make sure our scanner is connected. This thing is pretty much ready to go, so we'll create a new here we go. All right, back with it. So creating the project, we're going to do a standard blue laser mode. We're going to do cross line. We don't have any single line because of the RaptorX. And for the real-time res, I usually go 1/4 millimeter. That's enough detail without overburdening the machine in real time as it's trying to move all that data around. Okay. Now I always start the scan by pressing the play button on the scanner. And here I'm going to go just kind of calibrate my muscles a little bit to the object, make sure that I'm in the optimal range as much as I can. Press play again, start scanning, and you can see that the object is shiny and black. This is just an aluminum. I think there's some kind of clear coat on it, but I didn't do any prep on it at all. Just shiny bare aluminum here, and just kind of taking my time moving around here. I don't tend to move very fast when I scan. I find that it just increases the likelihood of picking up noise or losing tracking or whatever. So I take advantage of the multiple lines and the high frame rates to reduce the number of passes that I have to do, but not to necessarily speed up my movement with it. So here I'm trying to get enough geometry off of this thing so that I can model the holder that I want to do for mounting this thing onto the wall. But like I said, I'm not trying to get like a high fidelity scan of this thing. Otherwise I would have, prepped it, put some spray on it, A-sub or whatever. But here I just want to pull in enough reference geometry so that whenever I'm modeling the holder up, I can have this there and just be verifying visually in real time that what I'm modeling in Fusion is gonna work. So this is one of those things that's simple enough. You definitely could have just used calipers and measured the thing and just modeled it straight up. But having the scan of it is kind of a nice, real-time check that you can do while you're modeling. And you'll see that, I'm able to get through this first pass. It works, right? So I don't have to go off and repeat 2 or 3 times tweaking it because, the scan gives me enough data that it basically reduces the opportunity for errors here. So again, not trying to pick up everything possible, and I want to get enough of the circumference of it so that I can get an idea of like what the diameter is and fit the curves to it that are going to be holding it. I think I was pointing out in the earlier video clip there that I'm going to be basically building a cup that the bottom of it sits into, and then a clip that the top of it will snap in. And that'll make it real easy so I can just like reach over, grab the thing from the wall, pull it off and, go fight my Siths. And then it's really easy to put back whenever I'm done with it. All right, looks like I'm coming up on the end of the scan here. So just complete that on the scanner with long press on the play button there. All right, next thing we got to do, we got to come over and clean up all the extraneous data. I always like to just orient to the top and then select around the object that I want, and then I will invert the selection and then delete. Then I'll come over to the side and I will select a clipping plane here. In this case, because I didn't do a good job of getting, down low on the object because I didn't care to. Select all that noise plus the bottom plane, delete that, check it out, make sure I got everything. Oh, missed that little bit there. We'll delete it and looks good. Okay, so now we'll come up and next up you got to do is fuse, right? So, when this thing is collecting all the points in the point cloud, it's getting a lot of duplicates. So the fusion is going to go through and coalesce those, redundant points into a high quality point cloud and, remove, extra noise and, jitter, that's just kind of a natural, byproduct of, the scanning process here. So I don't need super high resolution on this, so I just went with 200 microns on it. I tend to use leave the noise removal at the default level. That really kind of suits my needs. In most cases I found, and then removing spikes and all of that, don't bother with it because, like I said, I didn't have a high quality scan here, so I don't want it deleting more data than I need. I can deal with the gaps and kind of spurious bits, but there was that one clump there that I'm not sure where those artifacts come from. When it was removed from whenever I did the point cloud cleanup, but whenever it goes through and fuses, it still had some stuff left in memory. So anyway, so now we're going to come over, we'll mesh, right? Again, don't need to go crazy on the triangles. 2 million is way more than we need, but whatever. I've got 128 gigs of RAM and a RTX 4080, and an i9, so no big deal for anything to handle those. And then, we got our model. So we'll go export that STL, and then we will jump over into Fusion, and I'll quickly show you guys, a quick way to get that thing, roughly aligned. And then we'll start modeling our part. Okay, so now in Fusion. So I'm going to go and create a new project. I always like to try to stay organized with this stuff. So I'll call this the, lightsaber holder or whatever, lightsaber project. And, Fusion always gives you a blank, design file by default when you start. So don't need to go create that. Just let's make sure that we're in that project for whenever we save it, make sure it goes in the right location. Okay. First thing I always do with the scans is I create a new component, which is the scan file itself. You don't want that floating around at the, root level of your project. It just kind of makes things messy. So once you have that, select and edit that component, then go insert mesh, select the STL that we just exported from CR scan, and here it is. I like to do it this way because that automatically interprets it in millimeters, so you don't have any weird unit conversions and have to go and do scaling, like you'll do if you just try to upload it. If you upload it, I think it'll pull in as centimeters. It's just easier this way. Okay, so the next thing I want to do, I want to try to align this. So what you're going to do is just, try to put a reference plane, on the part by selecting 3 points, right? What I'm showing here is that you can't do that directly. So what you need to do is you need to edit your component. I like to unground it as well. And then go into direct editing mode of the actual mesh. Then you can come in and see now it'll show you the vertices. So now you can add a plane by selecting 3 points, add that bad boy. All right, and we have a plane that's oriented roughly with the bottom of the lightsaber. Yep. So let's see where that is in space. I'll come over here. I'll turn on the origin, and you'll see that we're actually kind of far off. All right. So we want to get oriented with that. So what I'm going to do is I'm going to set it up so that it's sitting on the bottom plane, on the XY plane, with, you know, Z pointing up towards the sky, right? Looks like that one's upside down, so we'll give it a flip, and there we are. All right. Now, I'm not going to position this carefully. I'm just going to do it quick and dirty. You know, I could have added more reference planes and, you know, aligned those to the different planes within the coordinate space. But all I really cared about was is pointing up and down here, and I'll just drag it to be roughly, you know, I had the wrong entity selected there. So I'm going to move the component so that it takes the plane stuff with it. Oh yeah, looks like I have a little bit of wonkiness going on with that component coordinate space, but whatever, it doesn't matter. Like I said, you know, you can spend more time and do this more carefully. I tend to actually do my alignment to coordinate spaces inside of Quick Surface because I prefer that environment for the post-processing intermediate before I go into Fusion. But Quick Surface is stupid expensive, and you know, I don't expect most people to use that. So here I'm showing you how you can do that inside of Fusion. So now it's roughly aligned, you know, roughly positioned where we want it. So, you know, we can go off and create, you know, some geometry. So now that we've got it aligned, you know, one thing I'd like to do, just go ahead and pull out some measures just to verify. So get out my trusty Meditoyos and going to let's go ahead and save out what these things are. Diameters of those that I'm going to be hitting, you know, when I try to drop those in. All right. Yeah, it looks like I don't have my little picture-in-picture in sync, but whatever. I'm not a YouTuber. All right, so I'm jumping over into the mesh space. The first thing we're going to do is create some mesh section sketches. So with these, it makes it really easy to come in and kind of pull out the outline of your shape, and then you can do some things to derive from that. You can also then take your mesh sections, sketches, and you can, you know, create objects that, you know, approximate those dimensions. You know, so as you get more advanced into your, you know, reverse engineering within Fusion, it's got some tools there to kind of help you out. I create these mesh section sketches here. So I get the one for the bottom base, and then I'm going to create another one, just moving the reference plane up, and then we'll create the sketch on that plane for where my clip is going to be attaching. Okay. Why is this thing pausing here? Yeah, oh, looks like I changed my mind about where I wanted to grab it. I think I had measured up higher, but then when I was looking at it again, I'm like, yeah, let's go for the lower portion of it. I think it made more sense to grab it there. So that's what I was doing there. All right. So yeah, got the mesh section sketch there. You can see the two outlines. So all that trouble, and then I'm not going to use it. So, but it's there if you want it. That's how you do it. That's what you would use it for. So now I'm going to go create my base sketch. Look like you see there, that was a common problem, is that I still had the scan component selected when I went to create my sketch to start building the actual holder. So cancel out of that, and then go create a new component, you know, for the holder itself. And we're going to create all the sketches in that. Right. So I've got those planes that I created for the mesh section sketches. I'll just use those. Here I come in here, approximate where the circle is going to be. Draw that guy out. And looks like I'm probably doing a little bit of thinking on what the diameter is going to look like and all that stuff. So there we go. Go pull that up. And then once I draw that, you know, it doesn't look like it's going to be perfect, so I think I can come in here and look at it from the bottom, and then I will drag that to where I'm a little more happy with it. Now, I think I go through a cycle here where it looks a little loose, you know, so I'm going to play with the dimensions a little bit. I think I was like, I really wanted it to be 42 millimeters in diameter, but if you know, you know. It was just too big, right? So I had landed at 41, a bit too much jiggle. So here we're gonna go measure again and decide, yeah, it probably needs to be a little smaller. Where does that end up being? Is it 40 millimeters that I make it? Yeah, it looks like I made it 40. All right, good enough. All right, so we've got that. So now that's the inner diameter. So I'm just gonna go and offset that. I think I make this guy 2.5 millimeters. Thick. That should be plenty strong for what we need there. Finish that sketch. We'll extrude that up, and this is where the scan is incredibly useful. I don't even have to measure, right? I'm just gonna drag it and be like, yeah, that's thick enough. That's enough grip on the thing. It's not gonna come out of there. No problem. Okay, happy with that. Now we'll go create a new sketch, throw it on the bottom face there, and then we'll just project those two profiles, inner and outer. Bam. And we'll extrude again, select both of those, it'll fill in the hole. Yeah, 2 millimeters. Easy peasy. All right, so we got the bottom cup that this thing is going to rest in. So let's go up top and make our little clip, you know, our little flexure that this thing is going to snap into. So so I'm going to make a new plane and just make sure it's referenced off of that top profile, just in case there's any errors or anything. We want to get rid of that possibility. It looks pretty good there, and then we will create a new sketch on that plane. Here we're going to cheat. We're going to just project up the profile from the cup that we have below. That'll ensure that we're concentric top to bottom, but I'm not going to actually model off of that, so I'll convert that to construction geometry, and then we'll create the size rings that we need for our flexure based on our caliper measurements, you know, for what that ring segment is there. Again, you know, could have pulled this from the scan, but you know, calipers and the object sitting in front of me, so a little easier, right? And again, you know, kind of drove down my need to make a perfect scan since I'm just using this for reference. Okay, bam, same thing as below. Set that guy the way I want it. Come out here, offset. I think I went 2.5 again on that. All right, now we're gonna close this, extrude it up. How high do we want it? Yeah. Strong, we don't want it to be too thick, but probably 8, somewhere in there. Yeah, that's good. All right, so now we have our bottom retaining cup and our top, you know, clip, you know, flexure for it. Yeah, looks like I was, you know, not quite satisfied with how high it was. I wanted it a little bit more centered, so instead of like extruding down, I just went and modified the plane that it was sitting on, moved it down a couple millimeters, and feeling pretty good about that. Okay. So now we need to make I think the next thing I do is make that top. No. I think I add the bosses to it next. See what I do. It's a mystery. Voiceover is fun. So we need to make some bosses that will offset to clear the geometry of the lightsaber. And then we'll have the mount that will attach to the wall. So we're not going to screw this thing to the wall. We're just going to end up using some command strips, and just tape the thing on. Makes it easy to remove later. I don't like to tear up the walls, especially for things like lightsaber holders. So anyway, looking at that, yeah, it's not going to have to come out too far. So, all right, so we'll drag that over, get it somewhere inside of the ring. It doesn't have to be perfect, but close enough that it's going to attach into there. And because we have different diameter rings, top and bottom, right, we'll have to account for that as well later. But this is close enough to start with. So we'll come in here, we'll create a new sketch on that offset plane that we just created. We'll project in the geometry of that bottom cup. And so I like to get the top and bottom edges. So now I'm going to create a construction line, which is in the middle. So here I'm doing it one way. I'm creating, created the line perpendicular and then set a symmetric constraint. That's one way to do it. I could have also have what I'm showing here. You could have selected the midpoint on one of those lines and just drawn it that way in a single operation instead of doing the symmetry, but whatever floats your boat, I did it with a symmetric constraint for a long time before I learned about doing the midpoint thing, so that habit's still kind of in there, but midpoint is better. So now drawing a rectangle, right? So this will be the boss that we've got. So I measured the command strips. They're about 20 millimeters wide and about 75 long for the adhesive area on them. So sizing this 20 wide and then making sure that it's symmetric about that construction line that we had created. Okay. Come up to the top. Still on this same sketch, we're going to do the same thing. Project this guy in, make sure we get that geometry. And here I'll create that line. I believe this time I just do the midpoint. Bam. All right, see, easier. And then make sure to turn off construction on this. Draw that guy out. Same thing, some extra constraints. 20 on this. Could have set him equal to one below. Could have set, parameter within the project, but again, this is not a production item, so let's not get carried away with ourselves. We'll just set a dimension to move on with our life. So now we have it. So we'll select both of those profiles and we'll extrude them out to make sure that they clear that little nub that's on the bottom of the lightsaber far enough out that it clears it completely. Look good to you? Yeah. Looks good to me. See the gaps there? That's from the different diameters of the different rings. We'll come back and fix that. I'll show you a trick for that. So now I set this as a two-side extrusion, so I can go in both directions. So when I draw it the other direction, whoa, crash. So now I've got a problem, right? So it interferes with the inner diameter of the circle. So now the lightsaber won't fit in there. So whenever I extruded that, I created it as a join operation, but we can fix that by we can come in here, we can just say, make it a body. And that way, what we can do, come over to our browser, we can select those little bosses individually, and we'll be able to split them based on the inner cylinder of our different features, right? So here we'll split that guy, and the tool we're going to use, inner surface, bam. That'll give us two bodies out of this, right? So we'll select the one that we don't need. We'll just delete that. All right. Now we'll come and take these two, and we will combine them. Select that as our main body. That is our one to get rid of, our tool or whatever. And there we have a single body entity that That is the correct shape. Do it again on the top. That one, we're going to trim it with that. Bam. Delete the noise. Combine. Easy peasy. All right. So now they're still two separate bodies, but because we created those bosses as the same object, they're coplanar. So all we have to do here is just come in. I'm going to project these in to get all the corner extents in there. Draw a rectangle to connect them all up. And then we'll do a little extrusion. That will give us our back plane that will connect this thing up and make it whole. When we extrude this, we'll join it, and then you'll see that those two bodies become one, within the browser. Okay. Looking good. Now I'm going to put a chamfer in here just or a fillet, just to get rid of those stress risers. So there's going to be load on this, so let's give it a little chance of survival. All right, so the last thing we need to do is create our flexure clip at the top. Okay, and you can see how that's going to work now. Okay, turn that off. We'll come in here and we'll edit create a new sketch on the top. So we will project these in, we'll create a new center line coming out of the center of that inner circle. Make a construction. Bam. Okay. Create a new rectangle, not construction, because we will be using it to extrude. Make it symmetric. And then we're just going to eyeball it. How much grip do we feel like we need on that lightsaber? So what we're going to do is we're going to press in. Those things will flex out, and then as it moves past the midpoint of the cylinder of the lightsaber, they will start to close around it and retain the thing. Right. So that looks pretty good to me. Let's add a dimension just to feel good about ourselves, and then we'll just extrude it out and delete that opening. Okay. Looks pretty good. Now we'll do some fillets on these things so we don't poke ourselves or, nothing gets hung up on them when, because they're too sharp. So a nice little round edge will make it easy to slide right past. Do the inside as well because we're not animals. And a little bigger. All right. What do you think? Looks pretty good to me. That should hold a lightsaber. So here I'm thinking about how I'm going to print this thing, because a little tricky, if you know about 3D printing, and layer adhesion is not the greatest, especially on thin sections like that. So, the orientation you print this in is going to be critical for whether or not it actually functions. And what I've decided is that I'm not going to be able to print it the obvious direction, which is just like on its back, because it won't be strong, right? So, yeah, save your work. I should have saved it from the beginning, but luckily Fusion didn't crash on me. And then now we're going to do printer utility, export, get ourselves an STL, throw that over in our model directory, and then we'll go into Bambu Studio and set up this print job. So where are we at right now? So this is all running pretty much real time. So we're about 30 minutes in from having done a little bit of setup, did the scan, and modeled the part. Now we're ready to print. And I haven't really skipped too much. I mean, a few little jump shots here and there, but the transition between these, most of that work was just because I was trying to film this for you. This is about how long it would take to do in real time. So anyway, now we're in Bambu Studio. I always go to the device, and before I start setting up my project, I like to go and get the heat bed going. Just so it gives, time for the printer to kind of stabilize, because, boards can, the build plates can, take different shapes and stuff as they heat up. Bambu's not too bad about it, but still just a practice I like to have there. So I'm looking at this, and what we were looking at in Fusion, right? If I print it this way, the layer adhesion is going to be crap. I'm dragging it up to the front because I don't like to print everything in the center of the build plate all the time, because you're just going to wear out your PEI sheet, in that area, and then the rest of the thing is going to be good. So let's drag it up to the front and get some fresh PEI for this guy, so we got good stiction. So I'm going to print this in ABS glass fiber. I still have some of that in the machine. Super strong, dimensionally accurate. It'll do a really good job here, and it'll hold up well in the environment. All right, so here I'm just going to give it a quick gander of slicing in this orientation, enabling support so that we can get that cup to come out right. And it's fine. Like this would work. Those supports wouldn't be too terrible to remove, but the problem is going to be right here in our flexure. Right. So remember, as we insert and remove the lightsaber, those are going to want to spread out and back in. Right. And because of those layers, every single one of those layer lines is a stress riser. And, FDM printing just doesn't have the best strength in Z, right? So it's going to break there, right? So we're just not going to do that. So instead, what we're going to do is we're going to cut this part in two. And then we're going to orient it for best strength, right? Which will be contiguous lines around these circumferences, right? So orient them this way. Now we won't even need supports for this. There's not really any load in the Z along the back plane. A little, but we've got that nice fillet in there, so that'll help us out, and it's going to be strong enough. So that's a 20 millimeter. What was it? No, it was like 8 millimeters high, but it's 20 millimeters wide. So it's like, and here I've upped the wall count, basically make this thing a solid part. The back is solid. There's a little bit of infill in there, but the key thing is that within these rings, look at this, the filament is contiguous, right? So those are, consistent long extrusions all the way around that thing. That is going to make the part as strong as possible, so that it'll hold up well in use. Okay, we're happy with that. Slice it. It's going to take about an hour, hour and 15 or something. It's a little blurry. I can't see. Forget what it was. But let's send it over to that printer and let it run. I think I go get some dinner, and we'll come back when the thing is ready for assembly and installation. Okay, hour has passed, and forgive my house slides there. Dude, if you guys haven't used the Pyro grip plate from BQ, fantastic. This is an H2D printer, and the thing's just great. All right, so that is our part that we modeled. Right, we are going to now put it together. So tips of it are a little bit rough, so I'm going to use my 3D gloop, ABS, because this is ABS glass fiber. 3D gloop is like rubber cement. It's awful, but it basically like has a solvent, and like, you know, it is like the strongest bond once fully cured, you know, of any adhesive I found, you know, for 3D prints, you know, that's like readily available and all that stuff, and it doesn't require like 2-part mixing or anything, so it's just super easy, right? So the ends of that a little rough, so I'm just gonna smooth them off, make sure I get a good, you know, bonding surface there. These are just a little drywall sponge sanders. You know, you get a Home Depot, Lowe's, whatever. I like them. You know, they clean up really easy. It's better than keeping just regular, you know, sandpaper around in my experience. You know, personal preference, but recommended. So give it a little coat on both. Give it a second for it to start eating into the plastic, and then smash them together. Okay. So this stuff recommends some time for setup, but I'm going to show you a little cheat here now that I've got it together. All right, I have this plastic welder, right? So oh wait, sorry, jumping ahead. So I go ahead and try the lightsaber first, just to make sure that we're all good. It had set up enough that I was feeling like I could take a risk, but you can see there the back is still flexing a little bit too much. But check that out. You know, couldn't you know, as confidently easily get that on the first try without having done the scan first. So works as expected, fits perfect. Right. I think at this point I'm realizing that the back is not super strong, so babying a little bit so it doesn't come apart and I don't have to redo the glue. But I have a tool for this. So plastic welder with staples. So you can buy these things on Amazon for, I think this thing was like $17, just stupid. And then these things, you know, the staples, I buy those in packs of 1,000 for like $5 or something. So you want to put that across. You can get that, you know, little wavy thing crossing your seam multiple times. It makes it strong as hell. Right. And then here, just a couple seconds. Bam, pull the trigger, heats up instantly, mash it into the part, let it cool for just a second, and then bam, pull it right out. Now get your diagonal cutters and cut off the excess lengths of the staple. And when I do that, notice I cover because that thing is going to go to the moon if you just cut it. All right, so make sure you cover it so it doesn't go shooting into your eye and blinding you or anything. All right, pretty good. Let's go ahead and put another one in the back. Yep, those just pop right in. Pull the trigger. Bam, it's in. Let it cool for a second to set. Same thing, trim it off. All right, so little nubs, you know, if you care, you can go and, you know, clean those off, but Lightsaber is going to be hiding that. And then on the back side, we're going to have the command strips. So they'll take up that little bit of rise that it caused. Not a big deal, not worried about it. Okay, so I will take some more of the 3D glue and just smear it across the top. So whenever the staple goes in, it sinks in, but it doesn't necessarily seal back over the top. So I like to throw the 3D glue on there just to seal it back over and just make sure that we have the staple fully embedded and, you know, the plastic just, you know, fully coating it. All right. All good there. So let's let this dry up. All right. So now that thing is good enough. So I've got these command strips. Sorry if it's not centered up well. But we're going to go ahead and tear off the red sides. Stick them on. All right. It is ready to go. Just one more trial fit. Make sure we're happy with it. You can see it supports it nice and strong. So let's go stick it on the wall. See how this thing looks. All right. There it is. There's the lightsaber, just pops in, press it in. Bam. There you go. Aside from the printing, real time, all the steps required, start to finish. Hope that helps you guys.